Good evening, students. In this video we are going to see about AVL tree program. So this is a program for AVL tree implementation in C. So like other binary search trees, I am creating in the node of the tree by using the structure int key, which will be holding the value of the node. Then a node will be having two children, possibly two children, a binary tree, left child and right child. So I'm having the pointer for the left child and pointer for the right child. Then for the AVL tree, balancing factor is one of the very important thing. Always the tree should be the, and all the nodes in the tree should be the well balanced to 1. As we have seen in the previous video, it should be -1, 0 or 1. So all the node should have the height as one of the important variable. So there's a one extra bit of information we have to store in the AVL nodes. Then the maximum is a function which will be returning the maximum height of the left subtree or and the right subtree. So whichever is maximum, we'll be taking that as the height of the node. And height is a function which will be returning back the height of the a particular node. So here we are passing one node as a parameter. That node's height will be returned back. So we made it as a function. And max function, this is a logic. We'll be passing two parameters, which is maximum will be returning back. So these are simple functions. Then as like in binary search tree, I think the previous thing we have seen. Whenever we want to create a new node, whenever you are adding a new node in the tree, this function will be called. So which follows like the usual pattern. Malloc will be called, the memory block will be allocated, then the starting address of that memory block will be returned back to node, and whatever the key value you have passed, that will be assigned to the node key. And initially when you are adding a node in the tree, its left and right pointer will be initialized to null. So here also we are doing the same, node left null, node right null, and basically the height of the node will be initialized to 1. So node height 1. Return node, the address, the assigned address we are returning back. So whenever we are adding a new node, this function will be called. I'll be highlighting the function. This function will be called. Okay. Then two important functions we are having. Actually we are having 4 rotations: LL rotation, RR rotation, LR rotation, and RL rotation. But basically we are going to do only two kind of rotation. Either it can be left rotate or either it can be right rotate. LR is a combination of both. Do one left rotate plus one right rotate. And RL is first do right rotate, then do left rotate. Okay, so this is RL combination. So basically two functions we need. I have defined here the two functions. Right rotate, then left rotate. Okay. We can see with an example, we can see line by line how it works. Then in order to get the balancing factor of a node, we are using the get balance function. It is used to get the balancing factor of a particular node. What is the balancing factor? Height of the left subtree minus height of the right subtree. You just see height of n left minus height of n right. So we'll be getting the balancing factor. When the balancing factor is any other term apart from -1, 0 or 1, we have to call left rotate or right rotate accordingly. Okay. And insert node function will be called whenever you are inserting a new element in the tree. So this is a insert node function. Okay. So during insert node itself, we have to check all the thing. After inserting a node, whether the tree is balanced or not, or after inserting a new node, the tree becomes unbalanced. Accordingly, we have to take the action. Okay. So only up to this insertion part we are going to see in this video. Okay. Deletion part we can see in the next video. Okay. Now let us see with an example. So So I'm inserting a node. uh, let's see different exam, not this number, so that be easy for explaining the left rotate and right rotate. So first I'm inserting the value 5. Okay. I'm inserting 5. So when I'm inserting 5, there is no other previous elements in the tree. Okay. So what will happen? We are calling insert node and we are giving the value 5. So this insert node function will be called. Okay, this insert node function will be called. Initially the root node will be 0. Okay, it will be null. So what it is doing? Return new node. It is calling the new node function. So the new node function will be called. So here the function, it will be called, memory space will be allocated and the 5 will be stored in the place. The left pointer of 5 and the right pointer of 5 will be initialized to null, as we have seen. Then I am inserting another node. Okay, inserting another node. So this another node value is to be, let us take 7. Okay, let's take 7. When I am inserting 7, go to the insert node. Okay, stuck insert node. Now the root node address we got to pass whenever we are adding the new node. So the address of 5 will be passed here. So this node, okay, this node refers the root node's address. Here what is the root node? 5 is the root node. Okay, then the root node is not null, so it is having the value 5. So this condition will be failed if node equal to null. Now it is not null. When I am entering the first value 5, the root node was null and the space will be created and will be adding 5. But when I am adding 7, already we are having the root node 5. Okay, so this condition won't be true, it will be failed. It will be going to the next condition. Okay, if key means the node, the key value of the newly added node. What is the newly added node? 7. Okay, whether 7 is less than 5 or greater than 5. So this is what we are checking here. So key is 7. Definitely 7 is not less than node key. Node key is 5. So this condition also fails. Okay, then what is the second condition? Else if key is greater than node key. What is the key value? 7 is the key value. Node key is 5. So 7 is greater than 5. So this condition is true. Else if condition, this condition is true. Then we are calling insert node. Again we are calling this function recursively insert node right. Okay, the node right. So we have to add 7 to the right of 5. So this address we are passing, comma, key we are passing. So 7 will be added here. Yes. Now insert node right key. But what is the node right value? What is the value? It will be contained in the right pointer of 5. It will be null because when I have initialized 5, it will be null. Okay, so recursively when this function is called, insert node right comma key means actually the node right we are passing the null value because both the left and right of 5 is null. Okay, so again this insert function will be called. Now node equal to null. What is the node right we are passing? Null. So now during the second call this will be true, node will be null. Now what we are calling? Return new node. We are calling new node function here. Okay, so the space will be allocated for 7, the memory blocks will be allocated for 7 and 7 will be added here, and both the left and right pointer of 7 will be initialized to null. Okay. So this is what happening when you are adding a new node, and this is a function like the normal binary search tree. Deforming the tree structure so that will be clear for you. Okay, now I'm going to add another value. Let us take it as 9. Okay, I'm adding 9. Okay, so when 9 is added, again we'll be calling the insert node function. Let's go to the insert node function. And now what is the key value? Key value is 9. So the key value is greater than node key. What is a node? 5 is the node. Always we have to pass the root address of the tree. Always 5 is root. So 9 is greater than 5. So go to the right of 5. What is the right of 5? 7. Okay, what is the right of 5? 7. So 7's address will be passed. Now here node right 7. The node 7's address will be passed. So again recursively we are calling insert node. Now node equal to null? No. Now we are having the value 7. Okay. So again this key is representing 9. 9 is greater than 7. Okay, 9 is greater than 7. Again insert node right. So this part will be called. This part will be true. Node right will be calling. And what is the right address of 7? Now the right address of 7 will be null. Okay, the right address of 7 will be null. Okay, so again insert node will be called. So during the third call, what happens? Node is null. Node is equal to null, because what is the last address we got passed? 7's address we got passed. 7's right address we got passed. What is the 7's right address? Null. So this condition becomes true. And new node will be called. The function new node function will be called. So the memory block for 9 will be allocated and 9 will be added here and a link will be created. Okay. Okay, this will be added. Up to this it is okay, but this is a AVL tree, self-balancing tree. Okay, simply after adding 9, its function is not yet over. Okay, because at each addition it have to check its balancing factor. When I'm adding 7, the balancing factor of 7 and 5 is the balancing factor of 7 is 0, the balancing factor of 5 is -1. There is no problem. But when I'm adding 9, the balancing factor of 5 becomes -2 and the balancing factor of 7 becomes -1. So now what we have to do? We are having 4 rotation. Now we have to do which, right or left? We have to do left rotation because the right subtree is overloaded. Okay, the right subtree is overloaded. So do one left rotation. Okay. Okay. So that is what we are checking here. Whenever we are adding a new node, the height will be updated. Okay, the height of 9, height of 7 and height of 5 will be updated. Then we'll be calling the get balance function. We'll be getting the balancing factor of each and every node. Then what will be the balancing factor of 5? Balancing factor of 5 will be -2. The balancing factor of 5 is -2. Okay. Always the node represents the root address only. Okay. Now the balance is less than -2. This condition will be true. Okay. The balance -2 is less than -1, and two conditions are there in balancing. Balance -1 and two conditions. Here one condition, here one condition. But which will be called now means we got to do one left rotate. So this condition will be called. So you can check. Balance is less than -1. And what is the key value? What is the currently added node? 9 is the currently added node. So this 9 is greater than node right key. So 5 is referred as node. Okay. Check the right of node. Right of node is 7. Okay. So still 9 is greater than the node's right. Okay. So 9 is greater than 7. So this condition is true. Okay. balance also it is less than -1, and also the key value 9 is greater than 5's right, that is 5's right is 7. Okay, so this condition is true, then we are calling left to rotate function. Okay. We call it the left rotate function, and we are passing the address of the node, address of the critical node. Okay, now just look at the steps carefully. Now which address I am passing as a parameter? 5's address. Okay, so x is 5. Okay, I am writing for clarification. Okay, now this x represents 5. Then in the next line, x right. What is x right? X right is 7. Okay, x right I am assigning to y. Okay, so y is 7. Okay, clear. And who is y now? 7 is y. Okay, so y is left. Y is left is here, there is no node. Okay, so y is left is null. Okay, y is left is null. Okay, you can refer from the diagram also. I am assigning to the temporary variable t2. Okay, then look at the next line, y is left. Okay, I am assigning the x value. So what is x value? 5. X is 5. Okay, so 5 is assigned as left of y. Okay, y is left is equal to x. Okay, so x is 5. 5 is assigned to left of 7. Then look at the next line, x right. Okay, now who is x? 5 is x. X right is assigned with t2. Okay, that is 5's right is assigned with null. Okay, so now what will be the structure, the new structure? So 3 nodes. Now who is y? 7 is y. Okay, so 7 is y. So 7 becomes a root. To the left of 7, 5 is assigned as left of 7. So 5 will be assigned here. And always already the right of 7 is 9. Okay, so 9 will be in its place. 9 will be in its place. Now this becomes a balanced tree. Okay, so this is what the left to rotate code is doing. Just look at the code. Just look at this. Okay, line by line you just check what is x, what is y, and why we are assigning x right to y, and how we are balancing this. And finally, after assigning this, we are calculating the height of newly formed structure. So this structure have been reformed, or it is balanced to this structure. So again we are finding the height of 5, height of 9, and height of 7. Okay, so that is what we are doing here, finding the height. Okay, now similarly, okay, if you are seeing one example for right, it will be sufficient. Okay, let's have the value 4, 3, 2. Okay, so like this we are adding the node. I think again no need of repeating the how the insert node is used. Okay, like this node is assigned. So now it becomes a left skewed tree. So we got to do one right rotate. Okay, we got to move in this direction to balance the tree. Now just we can look at the code. Right rotate. Okay, so right rotate y. Okay, so y I am passing as a parameter. Now y is 4. Okay, here I am typing like y is 4. Then so y is 4. Then y is left. Okay, y is left I have to assign to x. So x is y is left. Y is left is 3. Okay, now x is 3. Next line you can see. The y value is assigned to x right. Okay, so x right is y value. What is the y value? 4. Okay, now who is x? 3. So 3 is right is 4. Okay, that is what we are doing in this line. X right we are assigning y. Then y is left. So what is y? 4. 4's left is null. Okay, we are assigning with null value. Then we are calculating the height of the node. Y is height and x height. Then for the newly formed trees height. Okay, so just look at the steps. So the left of 4 is 3. Okay, that I made as 3. So 3 will be the root node. Then x right is 4. Okay, so we are adding 4 here. Adding 2 here. Like this becomes a balanced tree. And for the balanced tree, for the x and y nodes, we are calculating the height again. So this way the right rotate works. So we have seen 2 examples, one for left rotate and another for right rotate. So checking line by line will be more clear to you. Okay, and LR and RR rotation is nothing but combination of this left rotate and right rotate. Okay, so one after the another it will be called. Okay, so the same kind of actions it will be done. Thank you.